Welcome back to the already fifth part of my electronic IP68 dual power throttle motor control contraption here. In the previous part, card here, link in the description, I showed you the first drawing of the final product. And in this part, we will try to build some parts, that is the levers with the handles, out of aluminum and POM. Enjoy! Here's again that first drawing. And meanwhile, I made a detailed drawing of the lever and the handles. And here it is. So that's the detailed drawing of the lever in 3 perspectives. And here is the detailed drawing of the handle. Obviously only 2 perspectives because, well, it's symmetrical around 1 rotational axis. The handle is quite simple. Well, it's a, a cylinder with the major dimensions 44 millimeters long and a diameter of 18 millimeters. And there will be a pocket here 37 millimeters deep. That's to take on a screw head here at the bottom. So the handle will be attached on that side. And then we have here at the bottom, for a length of 7 millimeters, a smaller 6 millimeter hole. When you manufacture that, you probably make a 6 millimeter hole first, drill through, and then you make that bigger pocket here. And of course we will do all this on the lathe. And here's my brand spanking new Proxon mini lathe in all its glory. For the unboxing, see the video card here, link in the description. And I already chucked in my POM round stock, and I also dialed it in as good as it was possible. There are a lot of videos out there explaining how to dial in a workpiece on your lathe, so I won't do that. I just wanted to show you that we are not really here completely on the rotational axis. So zero should be my high spot. Not quite. Aboutish 0, and then as I rotate it, my end here goes up to about 28 hundredths of a millimeter, and you see it's jumping around. So the stock itself is not very round, and then at the top we are at about 3. So here off center, off-centric, what's the word, about 25 hundredths of a millimeter, so 0.25 millimeters. And I was really disappointed about that until I put a straight edge, where is it? Here to that POM stock, and noticed that it's, it's not completely straight. That's in the nature of, extruded plastic parts. Anything else? That shouldn't be a problem, because the diameter of the POM stock, nominal 20 millimeters, is actually 20.5 millimeters, and we have to turn that down to 18 millimeters, so we get all that eccentricity out, hopefully. And I bought it a little too short. We have here now about 107 millimeter in length, and the final pieces should be 44 millimeters, so 88 millimeters. And when I chuck this in here, I can approximately, need to find a place to put my calipers here somewhere. Okay, so it's a little over 90 millimeters, so we probably could just turn it down here and then cut it in half, but In fact, I will first face it off here, then turn it down to, yeah, where I can. Before that, I make, of course, a center hole here, and we will insert a live center because, and this will be a problem for the facing operation, this is not very stiff, okay? This is plastic. So we will have, when we're facing this off, go really, really slow. But anyway, let's start with that. Side note, there is a metal piece here at the end of the lathe screwed in. So not aluminium, but steel. So you can actually use the magnetic base of your gouge to attach it here, which is a very nice feature. I'm trying to give you here the nicest view of that face as possible without hindering me in the operation of the lathe too much. So that should be a nice flat face here now. And now I take a center drill and yeah, we make a little center hole here for our live center. So this won't wobble around anymore when we are actually turning it down to 18 millimeters. So I have my tailstock chuck in here. Yeah, it came with a mailbag card here, a link in the description. And yeah, let's just put a center hole in here. Nice and slowly. And I'm using the hand wheel, you cannot see it at the tailstock stock. I have the live center in now in the hole, and I'm still staying at 1000 RPM, and the lead spindle here, the lead screw, will move the whole carriage about at 50 millimeter per minute. So we are really going slow here, but first yeah, and my compound is now at 0 degrees, and I locked that axis on the compound because I won't use it. So just touching off here. Oh, this is already enough material. So let the machine turn. Okay. This is an interesting effect. So this stuff is not only, probably can't see it. Now I removed it, but there was a lot of these, yeah, like hairs, which were not really wrapped around the stock, but are actually still attached to the stock. And we have, of course, to get rid of all that stuff here. And for some reason, oh yeah, yeah, that was wrapped around. Now it's clean, I think. And Yeah, that leaves stuff everywhere. And we are down to about-ish. Well, 20, still 25, 20.5 millimeters. I mean, this was really just a scratch, a midgen here. So let's take off a tenth of a millimeter now. Okay, we should be at 20.4 millimeters. Yups, about-ish. Okay, let's be bold and take off zero point 0.1, 0.2. Let's take off 0.2 millimeters this time. You can clearly see that, let me zoom in, I hope I don't forget to zoom out again. You can clearly see that the chips are now forming quite differently. I'm spinning here a continuous thread. It's really most interesting. This is basically one continuous thread here that spun around that thingy here. Maybe there's special tool steel available for POM and similar plastics, but I don't have it. So let's do what you shouldn't do and just move the tool back here without retracting it. Might leave a scratch, but hey. My hope is that it will scratch open that long POM thread there. And yeah, can you see that? Yeah, you can see it. It's a little bit dark, but yeah. Tool steel is cutting backwards to that thread here and is cutting it open. And hopefully I can remove it afterwards. Okay, just in case you're wondering, I was, I think 17, 18 the last time I operated a lathe. Not a mini lathe, a real industrial lathe. So from grade 10 to grade 13, grade 11 to grade 13. So what's can be considered senior high here in Germany. I did on a weekly base. Yeah, I wrote down my setting this time. I actually operated on a weekly base, practically, so once a week, lathe or some other machinery. And I can't get that off, but that's okay. Now let's get adventurous and we advance 0.3 millimeters. But before that, we should maybe measure where we are. And sorry, I totally forget to zoom in and out. I remember to zoom in, but I do not zoom out. So we are now at 19.8 millimeters. So yeah, let's take off let's go to 0.4. Let's double it, 0.4 millimeters. You see, I'm just slowly but surely trying out what's possible with that lathe. At least with POM, and the finish is really nice. The finish is really nice at that 0.2 millimeters. Anyway, let's get moving. Again, I have this continuous thread here coming out of the machine. Not really making chips, you know. But yeah, I have it under control this time. You can do the math how fast that is coming out here. Okay, now my phone is ringing. That will be my spouse, but at least until I'm at the end here, we will have to ignore her. I'm so sorry. Yeah, the things I do for you guys. And girls. Well, that remark is probably not very well received by girls or spouses of other men. I will show it to you, but I'm accumulating here quite some length of POM thread. Maybe we should do something with that. Maybe weave some POM fabric for a POM shirt. Okay, I call back my spouse now. I'm back. And here is my more or less endless POM thread. Okay, can I get this off? Oh, I need the pliers or something to cut that. But anyway, let's disengage the clutch and go back. Let's try and remove that stuff here. Good enough. And we are now at, well, 19.1 millimeters. So that was actually quite okay. But let's try 0.5 millimeters this time. $1.2 millimeters total. POM. Yeah. And we're down to it says here 18.1 millimeter. Yeah, yeah, I was a little bit aggressive. 18.1 millimeters. Yeah. So, let's make a finish cut here, just half of a tenth, 0.05 millimeters. And that should be it. Okay, I give you a zoom. Maybe we can brighten up things a little bit. Yeah, and this time the thread, yeah, it looks awful, but this is just because the thread, the very thin thread, is now, yeah, on the part itself. It's really astonishing. And as I go backwards, the thread is cut and ping. This is now really fine thread. I mean, 0.05 millimeter fine thread. And I think we can also take the piece now out of the lathe. Yeah, maybe I should measure the diameter first. Yeah, 18 millimeters, spot on. Perfect. And now you can really see these threads here. Never saw something like that before. I did tell you the last time I actually operated a lathe on a regular base was in senior high. So, yeah. But I must say, looking at that, give me a sec, the finish is quite nice. Okay, now let's put that in the lathe again, the other way around, and get that part here down to 18 millimeters. That won't take that long, I guess. I chucked in the part the other way around, and this time, because I don't want to mar that nice surface here too much, I put in some sheet aluminium here in the drawers. And by the way, when I'm facing that stuff here, I'm setting my compound to about 2.5 degrees. That's a recommendation from Proxon. Yeah, there was some chatter in between, but anyway, I'm just checking after that operation because there was so much chatter if we're still concentric, and yeah, pretty much perfect. Next step, center hole, I guess. Half of the work when actually working with such a lathe is really moving your compound and your tailstock around, so you have some space to perform the next operation. But anyway, that's a drawback. But let's just do the center hole now here. And I'm trying to give you a nice close-up. I'll try to give you this time a close-up view from the top here. Yeah, that's good enough. A bit grainy. And we're still at 1000 RPM, and this time we start right away with 0.5 millimeters because we know the lathe can take that. So we're at 19.5. So we should be able to take another 0.5 millimeters off. So 18.4. Now we have to be a little bit more careful. So let's say another 1/10 of a millimeter, and have also be careful with my tool here. (18.2). Yeah, 18.2 as intended. Okay, so let's do another 1/10 of a millimeter, and then we should be there. So yeah, you see a little edge here, but trying to judge, yeah, we're still a little bit on a little bit higher diameter on that side. Yep. So I make not a 0.5 millimeter, but yeah, 0.025. I just give here on the wheel. On the wheel I was on 0.2, and I just go here a smidgen more. A smidgen more. This should be 0.025 millimeters more. Yeah, there is something visible here, obviously, but yeah, I will have to live with that. But it's now, yeah, maybe you can feel it here with I could try to blend that in here with some something else, Scotch-Brite or so, but this is not metal. This is plastic. So we leave it at that. Now I'm feeling a little bit adventurous and yeah, maybe I'm also just lazy. But I think the next 3 operations will be drilling the 6 millimeter hole here through our cylinder as far as we can go. And then with the parting tool, not installed yet, parting off the first handle, and then continue to drill the hole through the whole cylinder. Yeah, let's try that. Okay, this is a little bit awkward, but I reached the maximum extent of my tailstock. So if I want to go any further, I have to move my tailstock. Yeah, the drawbacks of a small lathe. But when do you want to do an actual over 150 millimeter hole, long hole, 105 millimeter long hole in a lathe that size? I don't know if you saw that, but in between I had some difficulties. I don't know why, but then at the end everything worked fine again. So yeah, the chips came out. Chips, can you say to plastic part chips? Well, anyway, let's move the tailstock to the back again. And then we part about half of it off. Side note, the whole thing here, yeah, well, it didn't get burning hot, but yep, that was about the time I could hold it without feeling that I got burned. And the drill is much cooler because it's metal. But because that's POM, basically plastic, it doesn't conduct heat very much. So the heat basically gets from all that friction here over the whole length of the drill gets stored here in the piece. So we better let that cool down a wee bit before we part off. I completely removed the tailstock, so I had some space here to measure the actual length of my piece, which is about 102 millimeters. Yeah, I went wrong there the first time. And if you can see here, that's a marking at 51 millimeter, and I centered my parting tool on that marking. And these are actually the 44 millimeters, not centimeters, that was 51 millimeters, the 44 millimeters that I will need for my handles. So we have enough space here. And also if I go to the face of the chuck, yeah, enough space here. So yeah, let's part that off and hope for the best. That's actually the first time that the POM stuff is really, producing chips. Well, they are not electrostatically. They are not so. Yeah, they are neutral. They're not sticking to anything. Yeah, and that's yeah, with a 6 millimeter hole. The first part of the handle, of course, we have to face that side off. We also have to face that side off in a minute. But first we have to finish our 6 millimeter hole. I have to get in here, almost reaching the root here of the drill bit, but yeah, we have to do it. And again, I have to reposition the tailstock so we can actually get through. Okay, tailstock moved. Let's continue. Yeah, after you reach a certain depth, the POM chips are not coming out anymore. And then you get a lot of friction and things heat up. Anyway, we need to face that off as long as it's here in the lathe. After all that vibration and stuff, I dialed in that piece here, or the rest of that piece again. So we are again within, not even a hundredths. That's okay. I thought I'd give you a close-up of that facing operation from that angle here. The whole idea here with facing that now even if it's not at the final length of 44 millimeters, is so I can measure how long it is actually, so I can know how much I have to take off in the next steps. I took the piece out and measured its length. It came to 49.5 millimeters. Then I chucked it in again, making sure that it's really sitting against the face of the chuck. And I measured the length here again to see if I have here any delta, but it also comes to 49.5 millimeters, so I can control in between how much I advanced. Yeah, and then I dialed it in again, of course, and yeah, we're almost spot on again. And now I will just face it off to the target length of 44 millimeters. I probably do first 8 or 9 0.5 millimeter cuts here, to get into the down to the order of magnitude of 44 millimeters, and then I'll go finer. But I do that in a complete time lapse. Okay, I'm sorry, I forgot to switch on the camera, so you actually didn't see the first few cuts, and then the phone rang, and I lost count how many times I already advanced, so I measured again where we are at now, and I have to be careful here so I don't get into a hole. And we are at, well, 46.5, a little over. So yeah, a few more 0.5 millimeter cuts, and yeah, 3 more, then we should be at 45, and then we go slower. And I think I also forgot how many times I turned my lead screw. And we're down to 40, yeah, well, 45 point something. Okay, so again, 0.5. Getting a little bit nervous here, but that should be okay. And we're down to 44 point, yeah, I have to read that off camera, 44.8. So let's do 3/10 of a millimeter. And we're down to 44.6. Let's try that again, just to be sure. Yep, 44.6. So another 0.3 millimeters. Now it says 44.2. Let's try that again. Mm, 44.25. So let's take off 1/10 of a millimeter. Yeah, it's tedious, I know, but that's how it works. So first measurement is, okay, it's reflecting, I'm sorry about that. 44.23 was not a good measurement. Okay, I have to do that off camera. I'm sorry. I need that closer to my eyes. 44 point, still 44.2. I thought I took off a tenth of a millimeter, so let's take another tenth of a millimeter off. $44.1. Okay. Let's take half a millimeter off, 0.05 millimeters off. Now we're at 44. Yeah, let's call that 44. Let's call that 44. Ha! Next operation would be to create that 37 millimeter deep, 12 millimeter diameter hole here. And we start that with a drill bit, with a 12 millimeter drill bit, to remove the brunt of the material, and then we try something a little bit more delicate to really get a nice flat bottom at 37 millimeters. I marked here with tape where 37 millimeters are from the tip to the tape, so I won't go too far. Only problem that might arise is that going from a 6 millimeter hole to a 12 millimeter hole in one go is a bit too much. And so if I encounter any problems, I will go back to first drill a 10 millimeter hole. But let's try out if 12 millimeters is working. This time you get a top view, so let's see how this is working. So far so good. A little bit of chatter. I'm not exerting too much force here, it's really easy, and also the lathe is not slowing down. Just making sure to remove the material. Yeah, but the chips are coming out nicely. Okay, I'm at the end what my tailstock can actually provide, and I think I disengaged the thread in the tailstock. So let's get here the whole thing out and clean that up. And then I'll move the tailstock a little bit forward and we continue. Okay, last few millimeters. And the rest I have to do by moving the tailstock. And then we go to the next stage. Yeah, the problem here was definitely in between that I had too much material accumulating here and it was not going out. Also, the part is getting hot again. That only happens if I do really deep holes here, and yeah, just something to look out for. Now I have a router bit in the tailstock chuck, so 12mm diameter of course, and also teeth here at the front. It was also in a mailbag. Card here, link in the description, I guess, if I haven't done so yet. And I experimented a little bit to find a combination of washers here. So the length from the face of my bit to the washers is 37 millimeters. So we won't go too deep. Otherwise, you would yeah, turn a little bit, then get the whole thing out and somehow measure the actual depth, and then you go in for, yeah, by feeling a little bit and get it out. Yeah, would drive you crazy. That way we just have to go until the washers are touching the face of our piece. And also, on a positive note, this goes in here quite easily. So that basically turns free without having producing any chips, which is a good thing, because I don't think the POM chips would be removed easily here. They would clog up everything, and then things heat up and get complicated. But that should work for just clearing up the bottom of our pocket. Okay, I have to move that completely back to remove the chips in the pocket, because the chips have no way to go, and there's the POM is just smearing in there. But we only have to do that 2 or 3 times. So so here, yeah, they're all accumulating on the face. And then we can go back in. And hopefully, after 2 more or so of these cycles, we're down to where we want to be. Just some pressurized air here. Okay, that's it. And yeah, it were actually more cycles than I predicted. Because, yeah, the face of that router bit is not designed to take up a whole lot of chips. And yeah, it's skunking up quite fast. So yeah, in every go we took out about, yeah, that much here. Which is not bad considering, but yeah, our part is finished now. And here's the result. And yeah, I cleaned up the edges everywhere, deburred them with a knife, and I went in there with a 10mm drill to clean up that yeah, inside radius here. And yeah, it's functional, so my M6 screw will go in here, and it's sticking out at the end approximately 5mm. That was the goal. Or maybe it's a little bit less than 5mm, but that's okay. It's just supposed to grab the handle to the lever. Yeah, anyway, other dimensions. Okay, we know it's 18 millimeters in diameter. We were very, very exact there. And I also think it's pretty much, pretty much spot on 44 millimeters in length. And the depth of our pocket is, a little less than 37 millimeters, but I knew that it was only 36.9. Yeah, my washer stack. I will now finish the second handle. But I do that offline because it's basically exactly the same process. Not only basically, it is exactly the same tedious process. That's it for today. I had planned more for this video, like actually making the handles from the aluminium stock, but it got too long anyway. And so we take a break here and we continue with the handles in the next video. Till then, bye.